Namaste friends, welcoming you all to our digital Gyan episode. Today we will cover the implementation aspects of using Firestore in Go applications. Google Cloud Firestore provides real-time serverless document database. Moreover, it has seamless integration with Google Cloud services such as Cloud Functions and Cloud Run. Modern microservices can utilize the programming power of Go with Firestore database and build scalable, high-performance cloud-native applications. To use Firestore, we first require Firestore database instance to be created in Google Cloud Platform. Once created, set up Firestore authentication by creating the service account in GCP. For development environment, create and download service account key as JSON file which holds authentication credentials for applications to access Firestore database. If you are deploying the application on Google Cloud, GCP project ID which contains the Firestore database will be sufficient to authenticate. Refer this link from Google Cloud for more detail. To initialize the Firestore client in your application, install Firestore module and import the library. Create the Firestore client by providing context and project ID. Firestore client creation may fail if authentication error occurs. Hence, it is important to set environment variable Google application credentials pointing to service account key file in development environment. Now, application data needs to be mapped to Firestore document, which is JSON-like data model grouped under collection. To map application data with Firestore document, we need to define struct or map object in Go application. Every Firestore document in collection have unique document ID. Hence, it is important to decide unique ID in our data model. We recommend to use application generated ID as document ID to utilize efficient querying and create, read, update, delete operations.
As you can see here, subscriber object of type struct is defined with few properties such as name, email, etc. Firestore tag can be specified to bind field name in Firestore document with the struct object. Map object in Go language would be able to utilize JSON Marshal and unmarshal functions for binding the data. Performing create, update, or delete document operations in Firestore is very simple using client APIs. This is self-explanatory as you can see on screen. Filter query can have one or more where criteria. We recommend to apply limit on every query to avoid fetching large amount of document causing budget overrun. Order by query is supported by every index field in Firestore. Firestore maintains ascending and descending order index for every field by default.
Firestore supports atomicity through transactions and batch writes. Use transactions to ensure atomicity involving up-to-date reads and write operations. Batch writes can be used on server for writing data in bulk when data can be allowed for dirty read during the execution time. Transactions can involve multiple read and write operations. Note that only individual document reads are supported. No query-based read allowed. Also, read operations need to be performed first before write. In case documents are updated outside transaction scope, transactions will be retried from beginning. This process can happen multiple times. Hence, it is important to keep the application state specific logic outside of transaction. Transactions can also fail if client is offline. Unlike transactions, batch writes has no restriction on order of read operations or fetching documents using query. Hence, it has fewer failure cases. Moreover, it can execute even when client is offline. Let's go through the example of money transaction between sender and receiver. Within transaction, we first read the account document of sender and receiver to know the balance in their account. In case sender account has enough balance to transfer money into receiver account, we first update the balance field of sender by deducting the amount to be transferred into receiver account. Next, same amount is added into the balance of receiver account. Firestore takes care of up-to-date read of balance field and committing two write operations at the same time. In case balance of sender or receiver is updated outside this scope, transaction will fail and Firestore retry the transaction from beginning. While using Firestore in Go application, we share few tips to ensure robust, efficient, and maintainable code. Define model component in Go language for each data model. Determine the cost of querying beforehand to plan the budget of using Firestore. Add exemption to save indexing space for fields not required to be indexed. Develop generic functions for create, read, update, delete operations to enable maximum reusability across application. Always apply query limit. Firestore transactions need to consider multiple retry and also limit the number of documents in its scope for better performance. You can refer examples shown in this episode on GitHub. Thank you.